In the previous video, we learned about the functionality of the 4-digit 7-segment display. We explored what each pin means and how we need to connect them. And at the end, we made a simple project which showed the number 1, 2, 3, and 4 into our display. In today's video, we will check out how we can make a counter like in the movies, and also how we can use 4 individual 7-segment displays to get the same result as the 4-digit version. So without waiting, let's begin. First, let's start by explaining how a single 7-segment display works. A 7-segment display is an electronic display device used for displaying decimal numerals and some alphabets. It consists of 7 LED segments arranged in a rectangular fashion to form the number 8. Each segment can be lit up individually to represent numbers and some letters. Now that you know how it works, let's try to wire 4 of them together to make a 4-digit version. To do so, you have to connect all the same pins to a same ground and have a single output to the Arduino. For example, let's start by connecting all the A pins first. If you don't know which pin is for which segment, you can configure them according to this picture here. Connecting the other B to G pins follows the same rule, so I'll speed up our process a bit before we get to the step which we need to connect the common pins. After you completed the previous step, now it's time to connect them to the Arduino. I use the pins 2 for A, 3 for B, 4 for C, 5 for D, 6 for E, 7 for F, and the pin 8 for G. After that, as our next step, we need to connect the 4 common pins. We have 2 common pins in each of our 7 segments, and we will use one of them to decide that if we want that digit off or on. I use the pins 9 through 12 of Arduino to control the 4 common pins. Now let's run the previous video code on it to see if it works. It may not be perfect, but we see the values 4, 3, 2, and 1 on it. As I also said in previous video, it is better to use resistors in the way of our common pins, so I'll do so as well, real fast. Now let's bring our circuit to life. You can simply use a mini breadboard and connect the 7-segment into it. Our next step is to write a code to display a counter on the 7-segment. This is a crucial step, and it's really important to pay full attention to every little step. First, we will define an array of integers for our 7-segment pins. Then we will define the common pins as well. You can make another int variable for the count number as well. For example, I'm going to count down from 5009. Also this time, instead of turning on each segment one by one, I will make an array of the numbers 0 to 9 and define which segment needs to be on or off according to the chosen number. In this 2D array, 0 means on and 1 means off. Like in here for showing the number 0, we need to turn on all the segments, except the G segment. For other numbers, follow the same rule. Just be careful with the 1s and 0s. You also can find the code for this project in my GitHub. The next step is initializing all the pins as output. To do so, I get the help of the for loop. It will iterate 7 times, and in each iteration, it will initialize one pin as output. Next, we need to set the common pins as output as well. Since I'm going to use the serial monitor later, I need to activate it first by using the method serialBegin and passing the value 9600 to it. Next step, I'll define 2 methods. One is to get the number and divide it to 4 individual digits, and later, this method will pass that 4 digits to another method, which turn on the chosen segments according to the number we pass to it. In the first method at the beginning, we divide the number that we got by 1000 to get the 4th digit value, and since our variables are integers, it won't show the decimal points. Next, to get the 3rd digit, we will use the modulus operator and we will divide our number to get the remainder of it, and we will store it inside itself again. Now we will do the same thing again, but this time to get the 3rd digit, we need to divide by 100. For the 2nd digit, divide by 10, and after getting the remainder of number. The 4th digit is simply the remainder. Now it's time to pass these 4 digits to the 2nd method to turn on the correct segments. To turn on the desired digit, we need to set it to high first while keeping the other digits off. In here, I want to show the value of 5 as the first digit from left. Next, to turn on the LED segments needed for showing the value of 5. I'll use a for loop. The loop runs 7 times, and in each iteration, it will turn on one segment if its value is 0 in the 2D array that we had before. Make a small delay after the loop and do the same steps for the rest of the digits. Just remember to pass the correct digit variable to the loop. Now in the main loop, you need to call the first method with the value that you want, and at the end of the loop, you need to decrement it by 1 to get the count down. Also, when the value reaches 0, we want to stop and do nothing, and to do so, we will use a if statement to compare if the value is 0 yet or not, and when it reaches the 0, it will enter inside an infinite loop that does nothing. We are now all set with the coding part. So let's run our code and see the beautiful result. You can see that our counter started to count down from 5009, and it will go on until it reaches 0. Let me speed up the process a bit to see what happens when we reach 0. Just kidding. It will just shows the value of 0 forever. If this video helped you in any way, please don't forget to like and subscribe for more videos.